In this tutorial, we're going to talk about section 12.3, inscribed angles. And to the picture to the right, we have a circle, and we have points A, B, and C, and they create an inscribed angle, which is this angle right here. And every inscribed angle also creates an intercepted arc. In other words, the legs of this angle touch the circle so that it has this arc in between them. That is called your intercepted arc. And what's really interesting is every single inscribed angle has a relationship to its intercepted arc. And the relationship is that the measure of your inscribed angle is half the measure of the intercepted arc. And this is the formula for it. So if I wanted to find the measure of angle C, and my intercepted arc was 100 degrees, okay, the way I would find angle C is by plugging that 100 degrees into my equation. So I would say the measure of angle C equals 1/2 the measure of arc AB, which is 100 degrees, which we know to be 50. So it's that simple. Now, although the concept is simple, we can run into some pretty difficult problems. So let's take a look at an example. Okay, so here's our first example. There's a lot of things going on in this picture. Don't let it overwhelm you. We have to take this one piece at a time and be patient. Okay, so here we go. We're going to start with angle A here. And the reason is because this happens to be an intercepted arc. So this entire arc right here happens to have an inscribed angle, it looks like, of 60 degrees. Now, according to our recent formula that we have, the measure of arc A, we'll just call it A, if I take half of that, that's going to give me 60 degrees. Okay, so 60 degrees is the inscribed angle of that arc. So to cancel this out, I'm going to have to double that 60 degrees. So the measure of arc A measure of arc A, is 120 degrees. So that's the first part of my solution, and I'm going to go ahead and write it over here. Okay, so now I can actually solve for angle B. So let's take a look at its inscribed angle. It goes from P to R to S, and therefore its intercepted arc is this whole thing. And it's made up of two separate arcs that we have solved for. It's made up of this 30 degrees right here, and it's made up of this entire 120 that we just solved for. So in order to find the inscribed angle B, we are going to do 1/2 of the measure of that arc, which looks like it's PTS, and that should give us B. So I'm going to go ahead and fill in the 120 plus 30 because that's the sum. That's going to give us the entire intercepted arc. So 120 plus 30 is 150, and half of 150 is 75. Just like that. And a couple extra pieces of information. Number one being two inscribed angles that intercept the same arc are congruent. So what that means is here's my inscribed arc right here, and this is one inscribed angle. Well, if I have another inscribed angle that also has that arc as its intercepted arc, then those angles are congruent. That's all it's saying. Number two, an angle inscribed in a semicircle is a right angle. So in this circle, if I create a diameter, I now have two semicircles. And any inscribed angle I create using that is always going to be a right angle. So for example, I could make this angle, I could go from here to here. So this would be a right angle. I could also go from here to here. That's also a right angle. And I could do the other side as well, from here to here. There you go. They're all right angles. So that's what that one's saying. And last but not least, the opposite angles of an inscribed quadrilateral are supplementary. So if I were to create a circle, like so, and create some kind of quadrilateral inside it, so we can go from here, 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 and like so, then the opposite angles are supplementary. So this angle here plus this angle here would add up to 180. Or I could say this angle here and this angle here add up to 180. All right, so let's move on. So the last thing that we're going to talk about is a different kind of angle that's formed by a chord and a tangent. So let's get this picture going. So I'm going to go ahead and draw in a tangent line. So we'll call it C. And remember that a tangent line only touches a circle in one point. And then I'm going to draw a chord that is attached to C, since C is the point of tangency. So let's say I connect it here, and I'm going to call that B. Okay. So what's interesting about this is that if you have this situation where you have a chord that's touching the point of tangency, then this angle has a very special relationship to the arc that is measured between it. So this angle is being related to arc BC. And the way that it's related is by this. So I'm going to say that the measure of angle C, okay, is going to be equal to half the measure of arc BC. So what that means is this. If arc BC had a measure of, let's just say 80 degrees, okay, then in order to find the measure of angle C, all I have to do is divide that in half. So the measure of angle C would be equal to, oops, I did that wrong, would be equal to 40 degrees. Now, if you started with C, let's say that we knew that C was, let's go with a new number, how about 30? So the measure of angle C equals 30. And what if it asked then for the measure of arc BC? What is that going to be? Well, it's going to be twice as big. So twice of 30 is going to be 60. And that's it. That concludes this tutorial.